talks about the ratio rise to run that you just measured and the carpenter's guidelines that are above.
Just number.
Nope. Yeah, just 1 and 2. Don't worry about B. It's not. Okay, so it doesn't need it? Yeah, I want to see. What's on it? You're in class. She had yours is different, so that's good. We'll call on you.
Oh yeah.
Oh, yeah?
Okay. So this is like the carpenter's guidelines. So that's ratio. So it's like
Yeah, like this would, you want the ratio to everybody is okay? Yeah, that's good. Oh, my
Would anybody like to come up and draw their sketch of the stairs that they need to share for us in class? I have 1 or 2 people. Shannon? Can we erase this?
Yeah. Well, everybody knows where they're going, right? No questions? Geometry group 1 and 2? They're the ones that have to move. Okay. So the next time, the next
Could
group.
we maybe get one more person too, because I know Shannon measured a different set of stairs. So it'd be nice to compare. Any brave souls? Thank you. Yeah, that's what, yeah.
what's that? So it's whoever does that first. I can make contact too.
Okay, so as you can see, we have 2 different drawings, different set of stairs, like we were saying before. Stairs have different steepness, but looking back at the worksheet and what we know about the carpenter's ratio, what can we assume or what can we infer from this information? I don't know if everybody can say that. Do they fit the carpenter's guidelines or not? Shannon?
No, because it's like 20.
So it doesn't fit the ratio?
Yeah, later.
Okay, and you had this one, right? That was the stair outside. Okay. How about this one? Did we find out?
Amy?
You said no. A little bit about the opposite.
No.
So it was bigger than the carpenter's guidelines, a little bit, okay. And those are just guidelines, not all steps are fit that way, but we just thought that was interesting to share because it's a real world application and some things that builders pay attention to when they're constructing steps and houses and different things like that.
Okay, so we are talking about slope today, so that's where the rise over run stair activity came in. So just to review, probably for mostly everyone, slope is the ratio of change in the vertical distance to the change in the horizontal distance between 2 points on the line. And that can also be known as rise over run or the vertical change y over the horizontal change in x. So Tori's just writing that on the board right now. And we have some activities for you guys to work on that. Actually, it's in your packet, the next page. one is actually the back of the worksheet that you just did. Yeah. So we're just going to work on the top, and then you can work with the partner, and then we're going to discuss those answers as a class. Both are correct. Thank you. Both are correct. Yep. Notice the slopes of the lines, the differences in the lines. And I like it. Yep, good. Yes, each of these is right. So this one.
You don't have to worry about the bottom.
Okay. Okay.
Alright, is everybody finished working and ready to share? Okay, so for the first one, we have a line with a positive slope. What did we get as our answer for slope? And can you explain to the class how you found slope? You volunteers. Oh, sorry.
I got 2 points and I did it by subtracting 4 and 2 and 5 and 2.
Okay, now I have a question for you. Could you have subtracted 2 and 4 and then 2 and 5 and gotten the same answer?
Yes.
And how do you know that?
Because it would have been the same answer for the negative 2 over negative 3, which comes out to be positive.
Great, thank you, Beth.
Amy, I wanted to do.
We got negative 2 over 3, and we did 2 minus 4 over 4 minus 1.
Okay, good.
Okay, for the next part, it's similar task, but instead of looking at a graph, we're looking at a table. So would anyone like to share how they found the slope for that portion? Eight?
I did 0 minus 3 over top of negative 1 minus 0. And that was to do the y minus y over top of x minus x. And I got negative 3 over negative 1, which equals 3.
Great.
So that was my slope.
Good. And could you have
worksheet in the packet, and it's just finding slope using different representations. Some representations may appeal to others or be easier for you, but it's important to understand how to use the different methods. So you can work on those problems with the person next to you, and then we'll check in and go over the answers.
And we actually have the same problems on a bigger sheet of paper, so if you'd rather write on this. And this one, we are actually going to collect. So,
For a grade?
and we're gonna grade it, yep. Right, final grade. Now this is finding the slope and the y-intercept of the graphs and the tables. And the equations.
Do you have a question?
They can check.
Okay, so we're running short on time, but if this were a real classroom, we would definitely collect the paper at the end of the class period to assess the students' knowledge and what they learned from the content. And we would probably ask students as well which representation they found easiest to use and which appealed to them, because I know when Taylor and I went through it, I found the table easiest to use, but maybe she found the
Yeah, I
graph.
like the graph.
So, and just to see which method's most efficient, but that it's also good to know more than one way to go about solving the problem. So, yeah.
Yeah, so we're just going to collect these because we're running out of time. Everybody get a chance?
You're just one person. Did you plan that?
Yeah.
Thank you.
Yeah, we did definitely.